All right, so just real quick, looking at your question here. At time t, the position of a body is given by this function s. I copied it over into my little notebook here. So A, we want to find the body's acceleration each time the velocity is 0. And you give an answer there. So I don't know if you are able to find that or not, but I'll show you where they're getting the -6 and the 6 from. So first thing we want to do is to find the velocity. And you get the velocity by taking the derivative of the position here. So t cubed has derivative 3t squared. -12t squared, you bring that 2 down, we get -24t. The 45t, you're just going to take that coefficient, 45. All right. Let's also go ahead and find the acceleration by taking the derivative one more time. My 3t squared just goes to 6t, -24t goes to -24. All right, the question is asking us to find the acceleration when the velocity is 0. So let's figure out when velocity is 0 first, and to do that, you're just going to set your velocity function equal to 0. So that's that 3t squared minus 24t plus 45. Set that equal to 0. We can divide everything by 3 here. And then we can factor. So two numbers that multiply to be 15, add to be that -8 is -5 and -3. We have the two things equal to 0, which gives us the two solutions, +5 and +3. Okay, so what these times mean, these times represent the velocity to be 0. If I plug 5 into the velocity, I get 0. If I plug 3 into the velocity, I get 0. Part A is asking us to find the acceleration at those times. So in my acceleration, we're going to plug 5 into that. And if I scroll back up, remember this was acceleration. So it's going to be 6 times the 5 minus 24. 6 times 5 is 30, minus 24 is +6. We're also going to plug 3 into the acceleration. That's going to be 6 times the 3 minus 24. 6 times 3 is 18. And then 18 minus the 24 is the -6. So that's where they're getting the +6 and the -6 from. This is the acceleration when the velocity is 0. And if we think about what the particle is doing at those locations, so our particle is starting off going to the right, but then at t to be 3 seconds, my velocity is 0, so now my particle has stopped, but the acceleration is negative. So it stops here, and it actually turns around and starts going back the other direction. Then, at t to be 5, the same thing happens. The particle stops again, but this time the acceleration is positive, so it stops, but then it starts going to the positive direction. All right, so that's just kind of what the particle looks like. And that's the answer for part A there. All right, part B. Find the body's speed when the acceleration is 0. So same thing, we're going to take the acceleration, and we're going to set that acceleration equal to 0. Remember the acceleration up top there was 6t minus 24. So setting that equal to 0. Here we'll just add the 24, divide by 6, and we get t is 4. So this is when the acceleration is 0, but then we're asked to find the speed when the acceleration is 0. So we're going to take 4 and plug that into the velocity. The velocity formula up top here, 3t squared minus 24t plus 45. So we're going to do the 3 times 4 squared. I already forgot what it was. Minus the 24 times 4, I think, and then plus the 45. I'm just going to double check, make sure I got those numbers right. Yes, minus 24 t, and then plus the 45. All right. Just use your calculator or whatever you need to do to get this answer here. I'm going to have to use a calculator. So plug in all these numbers to the calculator to get an answer. This first part's 48 minus 96 plus the 45. Looks like we have a velocity of -3. So when my acceleration is 0, which means we're not speeding up or slowing down anymore, my velocity is -3. So that's the answer for part B. Part C. Find the total distance traveled by the body from t equals 0 to t equals 4. Here you have to be careful when it's saying total distance. Oh, sorry, I just thought about something for part B. My answer is not actually -3. That's the velocity. It was asking for the speed. And remember, speed is always positive. So sorry about that. Part B, speed is 3. All right, now for C. Where we have to be careful with C, the total distance traveled is that my particle actually goes forward and then backwards. So if I just find the displacement at 0 and at 4 and subtract those two things, That's not really what's going on with my particle. Because remember, my particle travels a certain distance. At 3, it turns around and goes back a little bit. So really what I should do is to break this up into the two different sections. The distance from 0 to time 3, and then the distance from time 3 to time 4, and then we're going to take the absolute value of that. So from t to be 0 to t to be 3, let's see what happens. If I plug 0 into my position function, I'm just going to get 0. If I plug 3 into my position function, so remember the position function was 3 cubed, it's going to be minus 12 times 3 squared, plus the 45 times 3, again just using a calculator to figure out what this is. I got 27 minus 108 plus 135, plugging all that in. I got 54. All right, so from 0 seconds to 3 seconds, I go from 0 to 54. So far, the first 3 seconds, I've traveled 54, and then whatever the units are for this question. Meters, it looks like. But then, from time to be 3 to time to be 4, I start going back the other direction. I already know what happens at 3. At 3, I'm at 54, but let's figure out what happens at 4. So if I plug 4 into my position function, that's going to be the 4 cubed minus 12 times 4 squared plus 45 times 4. Again, just plugging all that in. So you get 64 minus 192 plus 180. At 4 seconds, it looks like I am at 52, which means from 3 to 4, I actually travel an additional 2 units. I just happen to be going backwards, which means that the total from 0 to 4 was that first initial burst going all the way from 0 to 54, plus we then wait an additional 2 units, just happen to be going backwards. But we're just going to add that on because it was asking for the total distance traveled. So 56 for that one. All right, I hope that helps. If you have other questions about that one, just let me know.